I'm Evan Gudbestead, an instructor of application and web development at Rankin Technical College. In today's video, you will build the back-end application of a car inventory system, just like the ones used by car dealerships. We'll be using, and this is a mouthful, ASP.NET Core Web API version 9, which was released just 2 months ago, this last November. That means you'll not only be learning, but coding in the latest software, tools, and techniques available in the software development industry. At Rankin, we believe in learning by doing. That's why, alongside with the theory, you'll be building this application. I will be giving you hands-on exercises designed to sharpen your problem-solving skills and help you think like a professional developer. Let me show you what we will be building. Back-end developers will rejoice because we do not have to make our code sexy on the front end. We don't have to worry about that user experience. On the back end, we focus on functionality. And so what we have here is a RESTful API back end, again, built in ASP.NET Core Web API. And so we're working with HTTP, of course, and we're working with JSON, and we're working with HTTP GET requests, POST requests, PUT requests, and DELETE requests. And so we're doing CRUD operation on a car inventory website. Now, this is completely customizable. Obviously, we're trying to get the foundations down. And how do you mock up a front end in .NET Core? We can actually send mock HTTP requests using a .http file over here in .NET world. And so we can send these requests, and you can see we're doing the add car, so we're posting a new car. So of course, if you have a car website, a new car comes into the lot, you want to mark that available for sale, you need to add this car to your website. And so looking at this car, this particular car has an ID, a name, and availability. Of course, these are completely customizable. You're going to need a price, you're going to need a color, you're going to need all the options on this car, and you will learn to do that. And so we get kind of the foundations down, and then you can customize it from there. Now, of course, once you add a new car to the system, you might want to see a list of all the cars. And so here we've got 2 available cars. As we add new cars, can't click it too fast, but as we add new cars, we could see all the Model 3s that we have available. If for some reason we have a car that's marked unavailable, you can see we added car number 5, for whatever reason is unavailable, and we can filter down those cards to only mark which ones are available. You can get a car by its car ID, get a unique car. And so here we're going to learn to, of course, get a car by its ID. We're going to learn to do a PUT request, how to update that Model 3. Oops, it was a Model Y instead. So we got 204 no content, which is going to tell us that the update worked and our update operation in fact works. And then last but not least, a delete operation. So we're doing CRUD operations is kind of the take home from this, and we're working with a database in memory, and so this is how we will get started. This is what we're building. Let's get started. I'm going to touch briefly on tools and prerequisites that will help you complete this tutorial. I am using Visual Studio Community Edition, and you can kind of see the purple icon versus what many people are a little more familiar with is Visual Studio Code, which is this blue icon on my taskbar. The reason I use Visual Studio Community is because I've been writing .NET for a long time, well before VS Code was ever created, and Visual Studio Community has always been used in the .NET world. And so I do realize there are multiple tools that you could choose to use, but I am using Visual Studio Community. When you download and install Visual Studio Community, you will need to select ASP.NET and Web Development in the installer. So that's what we're looking at here, the Visual Studio installer. So you need to install that option in order to have these templates that I'm going to start with. And so once you launch Visual Studio Community, and the edition is 2022, so I'm sure Microsoft's going to be updating that version here, I would think soon. Let's go ahead and create a new project. Your screen might not look like mine, but we will need to find that create a new project button. And then we have to select a template. Now you can kind of see some of the templates I've worked with recently, and there are differences in these templates. And so the one we're working with here is the ASP.NET Core Empty. Okay, in order to find that, you definitely want to filter to C#, right? You don't want to accidentally spin up a like an F# or C++ back-end application, and we're going to select Web API, and that should kind of get you where we're looking to go, where we can find this ASP.NET Core Empty template. Actually, as it might just be Web, and scroll and find ASP.NET Core Empty. There it is. Okay, so you see an empty project template for creating ASP.NET Core applications. This template does not have content in it, and there are some different options there. This one's more of a templated option, and then there's a few different options. So we're going to spin up next, and I'm just going to call this my car inventory system. That's my solution name, and I'll just call this car.
Mr. G.
Your mic is unmuted, bro.
Inventory. All right. So, and I don't plan on having multiple projects in the solution, so I might just place a solution in the project in the same directory, and that should work for our purposes. Now we are selecting .NET 9 here, right? That's what we talked about on the intro, where this was just released a couple months ago. Configuring for HTTPS is fine. And as far as the top level statements, we're going to leave that unchecked. We're going to click Create, and it will spin that up. And this is what we see. Now, just so my screen matches kind of the default, I might decide to reset my window layout just to make sure. And you'll see that I have Solution Explorer over here just to kind of glance at the files. We have Program CS, which is just our hello world. And if we spin that up, it should return a string of hello world. Also, kind of the prerequisites, I mentioned some of the software, but obviously this is all built on C#. So it basically boils down to the more C# you know, the more prepared you are for this tutorial. If you've never seen C#, you can, in fact, code along, and you know, the more you know, the easier this will be to follow along. However, you can still follow along if you've never even seen C#. You just will have a harder time doing some of the challenges. Okay, which again, the challenges are kind of an optional thing. You can skip them, and I'll get more into the challenges here in a little bit. Okay, so we do get hello world. We can click this green play button, and it spits back a string into our browser of hello world. Again, we're not really too worried about the browser at this point. And so this is where we get started. Now, ultimately, we need to save our data somewhere. And so the convention that I'm going to use, and we could actually save this into a database. And, you know, as you learn, you know, more about this .NET environment that we're in, we will be working with databases, you know, in my class, and you know, if you follow along. However, for now, we're just doing what's called an in-memory database. And in order to do an in-memory database, we need to install a third-party package, or basically software outside of this default template. So in order to install a package, If you've come from the JavaScript world, you might be familiar with NPM. Our package manager in the .NET world is called NuGet. We've got a command line package manager console, and we've got the GUI. So let's go ahead and click on Tools, NuGet Package Manager, and let's go to the GUI here. And we're going to need to browse and find some packages. Now these packages have some long names. The first one is called in memory. And so I'll show you what I mean by long names. This is in memory, and this is inside of Entity Framework Core. And so we're installing a couple of Entity Framework packages. Entity Framework is how you can get your C# to interact with the database. Entity Framework is known as an object relational mapper. It's going to map your C# classes to a database. And whether that's a real database or it's just in your computers or in your server's RAM, in other words, in memory, which we're doing here, either way, it's all part of Entity Framework Core. Okay, so Entity Framework is foundational in a lot of ways to working with .NET applications. And so we're installing this package for Entity Framework. And then there's one more for diagnostics. I'm going to click Accept. And Microsoft Entity Framework Core in memory. Now let me see if I just search for diagnostics .entity framework. Okay, so that kind of is how we're going to find this package. We're searching for diagnostics Entity Framework Core, the full namespace Microsoft ASP.NET Core Diagnostics Entity Framework Core. We're going to install this in our car inventory system as well. Accept. We get the green check mark. Now if I go to installed, and might need to clear out that filter and refresh, we see top level packages, and those are the two things that we have installed. Okay, now I'm going to get your hands on your keyboard, and so the first thing that I'm going to do is I'm going to create a C# class inside of my project. So I'm going to right click on the car inventory project, and I'm going to add a C# class, and this is going to be my car class. Now again, this is kind of like this is the data that your application thinks is relevant to a car. And so what we're going to do here is auto-implemented properties. Okay, so if you're from the C# world, you're familiar with that. So you know there's get blocks and there's set blocks, and they have a convention for their casing. So I'm going to type in prop. It's kind of the hotkey. I'm going to hit enter, or excuse me, tab. Okay, and it's going to autofill a property for me. Now my data type is going to be int, and the identifier is ID. Now what's unique in Entity Framework, okay, in Entity Framework, which is again how we're going to map our classes to our database, the ID property is mapped to a database table column. So there's going to be an ID column, and this ID column is going to be a primary key column. Remember that primary keys uniquely identify each row, okay? And it's going to be auto-incrementing. So we actually, when we insert a new car, we don't have to give it an ID. The way this is kind of wired up by default, the ID will just auto-increment 1, 2, 3, 4, and so forth. And of course you can change that behavior, but that's kind of the default. Okay, so I'm going to go ahead and pause the video here and give you a little hands-on what properties should a car have. Okay, and I want you to add those properties to this class, and part of that is having the access modifier, having the correct data types. And so for example, if you have a price, it's probably going to be a decimal data type, and then the identifier and a get and set block. And so if I were to do the make, the model, now of course at this point you typically get what's your code auto completion tool is a question that I often get, and I do have GitHub Copilot enabled, so it's suggesting some properties. Again, I'm going to stop here. I want you to add your properties to your car class that are relevant for yours, and then I'll work with mine. When you resume, I'll go ahead and finish this. So go ahead and pause that video now. Now, I'm really not going to make my car class much more complex than this. I'm going to add 2 more properties. Again, I want to encourage you to write your own code and think for yourself. I'm going to add 2 more properties to mine. And just as a way to keep this code kind of minimal, I'm going to add a is available, and I'm going to add a secret, and we'll kind of get back to this because a lot of times in the database, you might store information in the database that you really don't want to send into the front end. And so I'm going to have this little secret property that represents a piece of data just like that. Maybe something that you do need to store about a car, but you really don't want to expose that to the front end in any sort of way, right? That would cause some security concerns. Okay, so my car class we're going to keep here. Now, the next sort of thing that we need to do is a little bit of work for Entity Framework. And in Entity Framework, there's a class called DB Context. And so I'm going to make a class that inherits from DB Context. And DB Context is just our way, again, of mapping our class to a database table. So let's go ahead and add this class, and I'll give a little theory here. And our class is going to be called CarDB. And this inherits from DB Context. Now, you're going to see I don't actually have DB Context, but we need to import this Entity Framework core. So when I inherit from this class, it wasn't recognized, so it added line 1 so that this class inside of this namespace is recognized. Okay, now I'm going to add 2 lines of code here that will wire up my my Entity Framework to this database. And so notice on line 7 we have a constructor, and this constructor takes in some options and passes those options up to DB Context. So this is kind of a vanilla line of code. I would consider this boilerplate. Okay, but line 10 is a little bit more interesting. Line 10 will create a set of type car. Remember type car? We just defined the class of car. So when you have a set of cars, we're talking about many cars. Okay, and the name of it is cars. So what is this really doing? This is creating our cars table in the database. Okay, so essentially we're saying, hey, we have a table, a set of type car, and we're calling it cars. This is the database table inside of the database itself. Okay, so this line of code is a little bit more interesting. Of course, these are get and set blocks for this property. So a lot of this is really strange when you see it for the first time. I remember the first time I worked with Entity Framework. It's like, wow, we have this auto-implemented property called identified as cars, and it's a set of type. It's just weird to look at. So point is, I understand if you're seeing this for the first time, how it could be a little strange. How I think of it, that I think you could benefit from is, hey, we're just creating the table called cars, right, using Entity Framework. Okay, now we have this CarDB class, okay, and we actually have to work with this CarDB class to create the database in memory, as we talked about. When we create the database, it creates the table inside of that database. So that's going to be back here inside of Program CS. And inside of Program CS, up at the top, I'm going to have that same using statement that we had before. We're going to use Entity Framework Core. Again, we had to import those packages for this to work. And we're going to use, here's a one line of code. After var builder, okay, line 3, you could see what var builder does, and this is what you get out of the box. You don't get a lot out of the box from this template, but it does build a web application, and it serves up a GET request to the root of that application that returns hello world. So you get this builder object, and builder is a type web application. Okay, so we're going to add what's referred to as a service to that builder. And if I kind of get that out of the way and explain that this is referred to as dependency injection. Okay, and I can explain dependency injection. But notice what this line is going to do for us. Here, we're going to add a database context. Again, explaining that a database context is that link between the class and the database. And our database context is CarDB. We define that right here. It inherits from DB context. And inside of our constructor, okay, inside of our method call here, we're basically saying, hey, let's use an in-memory database, and we're going to call our database car list. Now that's kind of abstract. You really don't need to use that identifier right here anyways, anywhere. But nonetheless, our database will be called our car list, which just kind of makes sense. Dependency injection will allow the CarDB, I'm going to word this a little differently, will allow the database to be injected into, it says into the controllers, into the methods that need it. Okay, so essentially, what does it mean to be injected? It allows, dependency injection will construct the CarDB object when it's needed. So a lot of times in object-oriented programming, think of it, you create a class and then you construct the class. Okay, but in dependency injection, we'll actually do this construction. It'll actually instantiate the class for you and then pass the class to the methods that may need it. Okay, so when I think of dependency injection, it will actually, again, what this is doing is it's constructing our object, our CarDB object, and passing that into a method. Let me show you what that looks like after one more line of code. Okay, now I've done this without this line of code, but this just gives us a little bit more of exception handling. So for our errors that we may encounter, you could leave this line out, but this is, you can see here, this captures database related exceptions. It can be resolved by entity framework migrations. Again, you could actually leave that line out and this tutorial would still work, but this just gives us some more error friendly messages for exceptions that may come up. Okay, so now we've defined our database. We've created a table in the database. We've added that database to our basically in memory. Okay, and then we're allowing this to be passed into some called of method handlers or event handlers, some endpoints, if you will, that will handle HTTP requests. Now, what are our endpoints, right? So, for example, you know, if we go to http://localhost:/, so this is just your computer. Okay, and so here we're kind of making up a port 5000 / get cars. Okay, so what we need to do now is we need to wire up. If we receive a request from the front end to a back end route, okay, we need to wire up a method to handle what happens when a front end request comes in. And so what's nice here is I'm going to prefix all of my routes with /cars. Okay, and so if I put this after line 12, so here we kind of have a web application, and we put that web application into our variable app that was template. I'm going to say that all of our endpoints start with /cars. So if you go to /cars, you know, /add, for example, that would be the route to obviously add a new car. And so what I want to do, okay, so here, instead of using app.mapget, when you have this route group, we now have what's called a route group, which will prefix /cars on everything. I will do cars.mapget, and when this happens, instead of passing an anonymous function here, instead of cars.mapget, I'm going to call a function getAllCars. Now getAllCars has not been created, so let me show you the method signature, and then I will see if you can piece the pieces together to return a car. So, well, maybe I'll show you one, and then we'll get you with your hands on the keyboard. Okay, so here's a method to get all the cars. Okay, I'm going to put this after run. Okay, and notice I do have a little explaining to do here, but let's just focus on the method. Okay, so here's a method, and it returns a data type of task iResult. Okay, so obviously this return statement returns an OK. Ultimately, this OK is a type of task. So the return data types match. I mean, that's the short version of this explanation, is that this data type and this data type has to match. Inside of our return statement, okay, actually before we get there, our identifier is getAllCars. This is an asynchronous method, allows us to write async await, which is an updated syntax, which is really nice to have methods that support asynchronous code versus synchronous code. This line's really important. CarDB, right? This is our parameter of our method. And notice we are passing in an object of type CarDB. Remember I talked back here about dependency injection. Dependency injection allows CarDB to inject it into the methods that need it. So what we have is a identifier called DB. Notice on line 24, this represents our database cars table. Going back here, we said there's the cars table. So we are querying our cars table with link. This is link syntax. Again, the more you know about C#, you would go on to learn about link. I'll briefly kind of pull up. If you're a little bit unfamiliar with link, you might want to refresh yourself on link. This is referred to as link method syntax. So part of learning link is learning there's actually two different syntaxes for using link. But a lot of the keywords, right, are in methods. And so, you know, select from, where, contains, a lot of the keywords are in fact methods instead of just individual keywords, you know, select from, where from, select. So they are the obvious distinction there is that you just have individual keywords versus methods. And so when we have a select method, this is link method syntax. And what you pass to the method syntax is a lambda expression. So we're selecting X, which is essentially a car. So you're selecting everything. This is the equivalent of like a select star from your table. This is just getting every car and returning it with an OK status. Okay, now notice my data type, car DTO, is is not recognized. We haven't created this data transfer object. So this allows me to explain DTOs by adding a new class. And I've kind of hinted at this, car DTO. And now we can see it's at least a recognized data type. And let's talk about data transfer objects. I kind of hinted that it is a very common scenario where your database, this class represents data you're extracting out of a database, might have some data that you want to keep off of it. Okay, so what I'm going to do for my DTOs, I'm going to include all of my properties that that are not sensitive, right? Obviously, a secret would be considered a sensitive piece of information. So when I'm inserting a new car, I might insert that secret piece of information. But when I'm reading from my cars, which is what we're doing kind of out of the gate here, getting all the cars, I don't want to return sensitive information to the front end. So in my car DTO, I'm going to include everything besides the secret. Now, I'm going to have two constructors here, and one is the default constructor, okay, to construct my car DTO. I'm going to have another that accepts a car object, and it initializes all the fields, ID, make, model, and is available. Okay, but notice the car DTO does not take the secret. So that's, again, this is just a security feature, if you will. DTOs, data transfer objects, are very commonly used in the industry to avoid exposing sensitive information out of the database. Okay, so I have this car DTO. You pass in a car object, and obviously a car object would have a secret, but this does not. And let's go back to program CS. Okay, now, we've got essentially an empty database, and we can call get our all cars, and when we hit the endpoint /cars, it would return an empty array. The next logical thing is to add a car so that we're not just returning an empty or an empty object. No, we need to add cars before we can get all cars. But I think we're at a point where we can try and spin this up and do a little testing. Now, there is a window that we will use quite a bit, and that window is off of View. We're going to find Other Windows and an Endpoints Explorer. And when we spin up our Endpoint Explorer, we can kind of see two endpoints, which are both GET requests, one at the root. If I go back to program CS, actually our root endpoint probably won't return anything for us. It'll be empty. But if we go to /cars, that should ultimately hit get all cars. Now what we do with this Endpoint Explorer is we right click it. So right click /cars and generate request. And so you can kind of see here it's looking at local hosts with a port, and that's our variable, the host address on line 3 /cars. Okay, so if I have this running, let me go ahead and shut it down. I'm going to click save. So this has generated a file, a .http file, and if you've used Postman before, what all this is a quick and easy way to simulate a front end. Postman and these kinds of tools are like front end, a little bit on steroids because it's really easy to send requests, back and forth. So let's click on send request. Of course, we need to boot this thing up. So let's click on the play button. Let this spin up. Okay, now if you get localhost, well, this is correct because we're no longer doing anything at the root. Okay, so you can actually just close this and send a request, and we're getting a status of 200 OK with an empty array, which is what I would expect. We don't have any cars yet, but in fact we are returning an empty array out of memory. Okay, let's have a little challenge here, and so I'm going to give you a method header, and I would like you to wire up a new route to call this method when adding a car. So here's the static async returns a type of task, result, create car. Okay, we're going to accept two. We're going to accept a car and a car DB. Now, regardless of this logic, okay, I would like you to wire a post request to the create car method. I might be repeating myself here, but go ahead and pause the video now. And if you'd like to wire up a post request, as well as kind of gave you a hint on towards some of the logic, wire up an add to the database inside. Okay, so what might that look like? Not a ton of code, but nonetheless we can. All right, cars.mapPost. Obviously this has to be a post request. Anytime we're adding something new, we are doing a post request. And the logic, which was semi-correct, is we are going to be adding this car to our database. They make a syntax really easy. DB cars table, add the car. And then we have to call a save changes. This is an entity framework method. We're going to call save changes async. Now what we're going to do, again, we're not sending the entire car object back. We're going to construct a DTO. We'll say var DTO is new car DTO car. Remember, this is not going to send that sensitive information of the secret back to the front end. And here our syntax for returning is a return. We're going to use typed results dot created and send the car ID created cars 1 or created cars 2 along with the object, the DTO object, back to the front end. Now what's nice about our Endpoints Explorer, if we refresh, we now get a post. And so we can generate a request that will allow us to post a new car. And so anytime we're posting a new car, we need to say, hey, we're sending across JSON. So here's a post request to /cars. And we're going to send the content type to application JSON. And we have a make, a model, a year. Now let's check our properties, right? So we've got, we don't have to worry about the ID, that's auto. Make model is good. We have is available and a secret. So let's go back here. Is available to true, and the secret, and obviously this is JSON, so we need quotes. Let me get this right. Secret in quotes. This might be, again, so this is just something we're demonstrating to hide out of the database. And so I'll just say sensitive info goes in here. Okay. Now no comma at the end here. I've seen that break. So we got a make, we got a model, is available secret, just double checking. A make model is available in secret. Notice the identifiers are all lowercase here. commas on all these on the end besides this last one. Application is currently running. If you're stopped, go ahead and start it back up. Okay, and again, we're not too worried about what the front end sees, but as long as your window down here is running, let's send the request, and we get a 201 created. That means it worked. And notice it does not send the secret back to the front end, right? So we kind of extracted that sensitive piece of information out. So you can't see that. You see the benefit of the DTO. And if I send this request a couple more times, we can create 3 new cars in the system with whatever properties. Now if I get all cars, we return an array of objects, and we are up and running. All right, I'm going to do a get a car by its ID next, and then I'll have another challenge where you can delete a car by its ID. Okay, so I'll demo a little bit, give you some pointers, and then have another little challenge. So let's go back to Program CS, and let's add. Okay, so right now, all we've had is /cars. And so when we go to /cars, we get all the cars. And when we post to /cars, when we post right here to the root of /cars, we can create a car. Okay, now this third one says, hey, when we have a get request that has a dynamic value here. In other words, this is we could pass a number here. We could pass a string. It could be, whatever the string is. Well, I guess by default, this is a string in the URL. But you could read this as a dynamic variable and in the URL. So we're going to pass that variable in the URL, wire up a get car method. So let's go to the get car method. I'll show you the method header. Static async task of iResult called get car. We need to accept the ID, which is dynamic coming from the URL, and car DB called DB. I'm not going to take that code suggestion and instead, but now we're going to be able to pass that value from the URL into this method. Now, of course, ID has to match that identifier. Those variable names have to match. And we are going to return, and essentially we're going to have a ternary operator here. We're going to, this is a really neat syntax. Okay, so let's break this down. We're going to do a database call, db.cars, find async. So we're going to find one car, right, versus this was just a select star. Okay, so we're finding a car by its ID. So this is going to look up one car. If that is convertible, if what we're finding out of the database is convertible into a car object called car, if that's true, right? So we hit this database, and if what is returning out of that database is a car, if that is true, return that car in a DTO, with a typed results of OK. Otherwise, return not found. And so this is a really neat C# syntax, that ternary operator. This is keyword for converting what's returned out of the database into a car. Obviously, this is going to return true or false. If it's true, you do this. If it's false, you do that. So a really neat syntax there. Okay, now if I come over here and I refresh this, we get a get request. And I can come over, we see if this is still running properly. If I get all my cars, I've got ID 1, 2, and 3. So let's pass in an ID of 1. And I need to pass it like such. Okay, get rid of those curlies. And sometimes we need to reboot. And so I think what's happening here is I'm not hot reloading properly. So let's reboot, kind of refresh, and let's add a couple cars. Car 1, car 2, car 3. Okay, get all my cars, and let's get a car of 1. Okay, let's get a car of 2. Let's get a car of 22. 404 not found. Okay, so sometimes, you know, just to get the new code recognized, you gotta reload, hot reload, if you will, or just shut it down and start over. Now, that was a get a car by ID. The next challenge is to delete a car by the ID. So go ahead and wire up a delete car by ID function. And I will pause when I find the pause button. I'll be right back. Alrighty, so the delete car is going to be map delete function. So if we have a post, a delete request, I should say, it's not a post, it's a delete, we're going to call this function called delete car. What does delete car look like? Well, you need to accept an ID, and again, feel free to try this on your own. You could pause here to wire up this function. It's very similar to what we just did with the get car by ID. So if I scroll down, there's get car, there's create car, get all cars. This was get car by ID. Here's another way of writing an if else, right? And so here is another way of writing that syntax. If the car is a car, we remove that car. So the big indicator there is just the function of remove, and save the changes, and then I return back no content. That's just considered the best practice. If you get a no content back, it basically means it worked. Okay, the delete operation worked. You don't want to tell the end user exactly what you deleted out of the database. You know, if they just give you the ID of 1, you don't want to say you deleted customer John Doe. Okay, you just want to give them back like, hey, it worked, move on. Otherwise, return not found. So, you know, this is a kind of a condensed syntax for doing the same thing. Again, but here we had to call save changes because we are modifying the database. In this case, we're just reading out of the database. We didn't have to call save changes. Again, when we called create car, we had to call save changes. So these methods are real simple: add, remove, and so on and so forth. Now we've got a delete operation. Let's generate the request. I'm going to reboot this because we've already seen that is necessary. And I'm going to say delete car 2. Okay, so let's boot it up. Okay, nothing there, no big deal. We're not worried about the front end. Let's send some requests. Can only click so fast. Now we've got 3 cars in there. Reading our 3 cars. And let's delete car 2. Notice you get back the 204. Remember, 200s are success. So you're basically saying, hey, it worked. No content is all you're getting back. Good practice. And if I go back up to all my cars, we got ID 1 and ID 3. We've deleted the ID of 2. Which is great. Now, always the edit operation is a bit challenging. And so let's wire up a put request. Let's go back home. Let's minimize these methods and wire up a put request. So there's our methods. Clean that up just a little bit. And we don't need these comments anymore. Maybe put this request under that one, just for a little organization. There's a create car. Let's put our put cars.map put. Okay, now put is what's used for an edit operation. And we're going to update a car by its ID. And this will be update car is the function that we call. Let's put that variable inside of the curlies. Let's create the function update car. Static async returns a task of iResult update car, and we actually need 3 parameters on this one. Of course, we do need the ID. We need a car DTO. We're not going to allow them to update the secret, so we're going to only pass in. Now, you could, if you want to allow them to update the secret, you would accept a car, but we're not doing that. We're just accept the non-sensitive data. We need access to the database. Okay, so there's the method header. And we're going to start by reading the car out of the database. And if the car is null, we are going to return typed results dot not found. Okay, so we're going to start there. If they pass the number 22, you're not going to update a car 22 that doesn't exist. Now, this car is what we read out of the database. Car DTO is what came from the front end. So we need to update what came out of the database to the values that came from the front end. So we're going to do that with car.make. So we're updating what came out of the database with what came from the front end. So that's what line 33 does with the make. You can imagine the model's just the same, is availability. We do not update the ID. And let's see if there's anything else, right? Car DTO, the make, model, and is available. So really those are the 3 fields that we can update there. Then all we have to do is save the changes. Await TB, save changes async. And we're going to send back a success message that again is just going to say no content. Type results dot no content. Not giving the front end too much other than a success message. If you want to actually, I guess we could send back like the updated object, right? There's no harm in that because it doesn't contain the secret. Okay, so let's save that. And so there's the update. Let's refresh. Let's reboot. All right. Here's our put, generate the request. And just like before on our put, there's our put. We need to set the content type to application JSON. And let's just change it to something totally different. Right, we'll just update it to a Tesla Model Y. Model Y. So we just reboot. So our first Toyota Corolla goes in the database. Our second Toyota Corolla. And our third Toyota Corolla, we now have all 3. And if I scroll down and I update the third one, /cars/3 put request, doing an update operation, and we're changing that Corolla into a Tesla Model Y, you can see it spits back 200 of OK. It spat back the data that it's not available. If I go back to listing all my cars, you can see we got a couple Corollas and a Tesla now in our database. All right, one last challenge for you is to wire up a route create a route and route handler to determine, excuse me, to return the cars that are marked as available. Okay, and so obviously, you know, our car has this Boolean field for is available, which can be true or false, and I want you to wire up a list all of the cars that are available. And so the idea here is if you sell a car, it is no longer available. So users don't want to see a list of sold cars. Maybe they just want to see a list of available cars, or maybe they only want to see a list of sold cars, right? There's scenarios for both, right? So let's go ahead and wire up that route handler, and I will pause the video here for you to wire that up. The secret sauce on this one is just a little knowing your link queries and knowing the different methods that you have available to you when you're working with links. So the signature, you might, you know, have this at /available. So it'd be /cars/available, and the method signature, well, we really only need to accept one parameter, which is the car DB. Notice that all of our functions that have to inject that object of car DB. And let's see if IntelliSense got this right, or Copilot. Here we're returning type results of OK, db.cars where, and this is right, where that car dot is available is true, right? So where X, when you could, you know, a lot of times it helps to rename X as like car. Okay, where that car dot is available is true, but again, kind of convention. And then you select that car. So you say a where clause and a select clause. So very similar to SQL. Link is very similar to SQL. Just in Link, it's from where select, from the cars table where method select method. In SQL, it's select from where. And so SQL, conventionally, Link, they're just opposite orders. And the method then is toArrayAsync, which if I get all cars, you know, that was the method that hopefully I didn't glance over that too quickly. toArrayAsync takes all those objects and puts them into an array asynchronously, obviously, as the name implies. And so we can save that and refresh our Endpoints Explorer, generate the request, boot up the back end, insert a couple dummy cars, 1, 2, 3, get all the cars. Now they're all available, so let's make a couple not available. Right, so 4 is not available, 5 is available, and if I scroll down to what was created, so now I'm going to get a get request /cars/available. You can see 1, 2, 3, we skip 4, and we get 5. So simple link query to modify the query itself with a where clause to filter down that list. All right. If you made it this far, please let me know what you think, if you found this useful. I realize building RESTful APIs you can do in a bunch of different languages, but this is a very modern approach for building RESTful APIs in .NET Core version 9. So I hope you enjoy an updated tutorial, you know, how this code can be written here in the beginning of 2025. Please let me know what you think, and thanks for following along.